Good afternoon to my algebra students. The purpose of today's screencast is to cover some more of an introduction that we began working on last week with graphing points and lines on the Cartesian plane. You'll remember from our class that the Cartesian plane is broken down into two axes. You got your x-axis that runs right and left. You got your y-axis that runs up and down. And the points that we plot fall into one of four quadrants or on one or both of these axes. And remember that the first quadrant is the one that's to the top and right. And then we go around counterclockwise, quadrants 2, 3, and finally 4. So that's a bit of a review. What we're going to talk about today is how to graph out several points that fall on the same line. So for example, if I were to plot out a point here and a point there, and let's maybe make it right over there. Those 3 points all fall on the same line. We call that collinear, by the way, when points fall on the same line. And today we're going to talk about how to graph out the line that connects all of those points. And the equation that you're going to start off with is an equation that looks like this. It's ax plus by equals c. This is what's known as standard form. The standard form of a linear equation. And this is something that you most definitely want to memorize. Ax plus by equals c. And that is where a, b, and c are real numbers, and I have a little bit of a looser interpretation on it than most texts. In fact, I think the text that you guys deal with would probably say A, B, and C will be integers, and that's fine as well. That just means positive or negative whole numbers, counting numbers, if you will. But anyway, the standard form is something that you definitely want to be familiar with. So for example, if I gave you 5x plus 3y equals 15, that is a line, that's a linear equation. The equation's graph is a line, and that equation is given to us in standard form. So we can do things like identify what A, B, and C are. So for this example, ask yourself the question, what do you think A is? Well, A would be 5. What do you think B is? B would be 3. And what do you think C is? C would be 15. That's pretty straightforward, pretty plain Jane information. And what's nice about a linear equation that's in standard form is you can kind of tell some things about it. Now, I've given this example in red, so let me get these blue, if I can, these blue points off of my graph there. And what we'll do is we'll practice graphing this line here in red. So first thing you want to notice is that there is an x and a y. This is a two-variable equation like we're used to dealing with. And so what you can do is you can plug in a particular x value and figure out what the corresponding y value would be. So for an example, if I said, hey, let x be 0. So let x be 0. What would the resulting y coordinate be? So if I said let x be 0, that's like plugging in x equals 0 and solving for y. So we get 5 times 0 is 0. Divide both sides by 3, and we get y equals 5. So when x is 0, y equals 5, that is an ordered pair, and we would go 1, 2, 3, 4, 5 units up, and we would plot that point of 0, 5 on the x and y axis. Okay. Again, the x and y axis is how you're going to plot each of these points. And I just chose let x be 0 because that's a special point known as the y-intercept. Right? We could also pick another value. We could say, hey, well, maybe I want to let y be 0. So let y equals 0. In this case, I would plug in 0 not for x but for y. And then I'd solve for the resulting or the remaining variable, our x, our corresponding x value here. So I would divide both sides by 5 to undo that multiplication, and just like we did over there in the first little bit. And so now we've got x by itself, and 15 over 5 winds up being 3. So our point here, earlier it was 0, 5. That was the point on the line. Here, this is 3, 0. That's going to be our point on the line, and we could graph it out just by, again, going on the x-axis 1, 2, 3. That's the x-coordinate. 0 is the y-coordinate, so we went up 0 units. We went to the right 3 units. Now, I'm one that I always like to get a third point if I can when I'm plotting out a line, and we certainly can do that one of two ways. We could pick another x or y value and solve for the corresponding, the other variable that's left over. Or we could kind of recognize there's a pattern going on here. We could kind of think, this looks like from my first point I went down 5 units and to the right 3 units. So I wonder if I could go down 5 more units and to the right 3 more units. Those of you that have had a little bit of experience with algebra before, you'll note that that's the notion of slope, right? It's the idea of rise over run. And so like you might think, hey, if I go down 1, 2, 3, 4, 5 more units, and I run to the right 1, 2, 3 more units, then I'll get to my next point, the next point of interest at least, following along with this pattern, and that point would in this case be 6, comma, -5. So that's one way of looking at it to get that third point. Another way would just be to simply say, hey, you know what, let me pick another x value. Let me say, here we'll let x equal, and then you try and you choose something. So maybe I'm not smart enough to figure out what x value to pick. Maybe I'll pick something like x equals 1. Okay, well, if I plug in x equals 1 and I solve for the remaining y value, I'm not going to get a very pleasant value. In other words, 5 times 1 doesn't go away, it becomes 5. And then solving for the remaining y value, I need to subtract 5 from both sides. That goes away. 3y equals 15 minus 5 is 10. And then divide by 3. And I notice that 10 doesn't divide by 3 very evenly. In fact, I get a mixed number, 3 1/3. Now, while that point is legitimately on the line, 3 1/3 is not, as I mentioned, a very pleasant value to kind of graph out. In fact, you could see that. I'll use green to denote the difference here, but 3 1/3, 1 comma 3 1/3 is what I would call like an in-between point. Yeah, it's on the line, but it's just not really a point that I can comfortably graph with great certainty as far as tick marks are concerned. So although that is a point that's on the line, it's probably not a smart x value to choose right there, letting x equal 1. And in fact, if you kind of pick up on the pattern as we mentioned, the next smart x value to choose would be more in line with x equals 6. So for instance, if I said let x equal 6, then plugging in 6 for x is going to make a much more easily graphable, we'll say, point. So 5 times 6 would be 30. So I've got 30 plus 3y equals 15. Just subtract 30 from both sides. Whatever I do on the left, I do on the right. So I've got 3y equals -15. And then divide by 3 on both sides. Divide by 3, divide by 3. And we're left with y equals -5. And again, that point there of 6 comma -5 is a much nicer point than the one in green where I had to kind of go in between the tick marks. So last thing that I would do here, and I usually am pretty terrible at doing this on my screen, is to connect the dots in a straight line. As I mentioned, that's not super great, but oh well. Connect the dots in a straight line, and what you've got now is you've got the graph of this particular linear equation. It was given to us in standard form, and that's how you would graph it out, by picking a few x values. I will end this example by saying a lot of times some of the students that once they get the hang of it, they don't do all of this work for every single point. What they'll do is they'll make an x and y sort of chart or table, and they'll pick certain values like 0 or 3 or 6, and then they'll just plug in those corresponding values. So I hope that makes sense for this example, and we will work some more in a later screencast. So thank you very much.